Hello guys, I hope you are doing good. Welcome to the 11th video in the series where we'll be implementing the throttle function. Throttling is a optimization technique in which we reduce the number of function calls in a specified duration or based on the number of invocations. So if you have seen, I have solved the first problem, create a sampling function, which is a variation of throttle that invokes a function once in the specified number count. Let's say if I have given the count as 4, I'll be invoking the function once in every fourth count. In this throttling, we have the same restriction. We invoke the function once, but in the specified duration. So let's say if I have passed 1000 as a duration, then this function, whatever we are passing on the click event, will be invoked once every 1000 milliseconds. So it is a optimization technique similar to similar to debouncing, but throttling invokes the function once in the specified duration. Debounce invokes the function once after the last click and the specified duration. So let's implement the throttling. Before writing the solution, I just wanted to give a heads up on my course alpha.learnersbucket.com. If you are preparing for your front-end interviews, do check out my course. I have everything that is needed to crack a front-end interview. And here is the list of front-end system design questions. I have around 17 system design questions, which is the most available on the web at the most affordable price. And as you can see, I cover everything from food ordering website to collaborative text editor like Google Docs, form enrichment shortener, newsfeed, and then Pinterest, Instagram, e-commerce app, even JavaScript coding platform like LeetCode, messaging app like Slack, house booking like Airbnb, meeting booking like Calendly, music streaming like Spotify, and then video conferencing like Google Meet and Zoom. So if you are preparing for your interviews, do check out my course. Coming back to the question, let's try to implement this. Let me close the side drawer. Here we have the throttling function. Let me clear everything from here, and then we'll have a button with the ID. So button slash button, and then here we'll say test, and then we'll give an ID test button, and then let me copy things from here. Let me go to script, replace this. So here we have to implement this throttle function, and on the click of this button, this function should invoke once in every 1 second. And let's say if I change it to 2, so this should invoke once in every 2 seconds. So if I reload this, you'll see I have this button, throttle is not defined, it is throwing an error. If I remove this throttle and if I have a normal function, you will see that the console log is being invoked on the every click. So as I'm clicking, the message is being console logged on every click. With the throttle, this should be logged once in every 2 seconds, or the specified duration that we have. So let's start implementing the throttle function. Throttle is similar to debouncing, but we just have to invoke it once in every specified duration. So here as well, we'll be making use of the set timeout function, and we'll be handling it to invoke this once in the specified duration. Also, we'll be using closure. We'll be forming a closure with the variables to keep track of the timer IDs. So let me implement the throttle. Throttle will take the function and the delay as input, and it will return another function. So it will return a function, and as I had explained in the debounce video, the context and the arguments from this return function should be passed to the input function, so that whatever we are having should be available on this function as well. For example, on the click event, the event should be accessible in the input function, so that's why this return function, its context and argument should be forwarded to the input function. So for that, I'm going to have this context equals to this. This is the special keyword available within the function. Watch my video on the JavaScript revision to understand how this keyword works. And then we'll have the arguments. So arguments is also a special keyword available within the function that gives list of all the arguments that this function has. You can also have the arguments like this, which is the modern syntax of using the REST operator, or you can use the arguments keyword and then also access the arguments. And now what we are going to do is we are going to invoke the function. So to invoke the function, we'll check if the function is last invoked or not and when it was invoked. So we have to keep track of two things. If the function was last invoked, if it is not invoked, then we'll invoke it immediately. And if it was invoked, then when it was invoked, because we have to invoke it once in the specified duration. So last timer ID. So this will give us when the last time function was invoked, and then let last ran. So when the function was last ran, and here we'll see if not last ran, which means this is the first time invocation. So we'll say that function dot apply context and args and invoke the function immediately and update the last ran to date.now, which means this was invoked immediately. Otherwise, if the function was invoked, then we have to add a check. So clear timeout. If the function was invoked continuously, so we want to reset the timer. So for that, I'm going to clear the timer ID, and here we'll say that last timer ID equals to set timeout. Set timeout returns a timer ID which can be cleared, and then inside the set timeout we are going to have a condition if date dot now minus last ran. So if the current time and when the function was last invoked is greater than or equal to limit, which means the last function was invoked before the time limit, so we can invoke it again, then we'll do function dot apply and we'll pass context and args to it, and we'll update the last ran with date dot now. And similarly we'll set the time over here. So here I'm going to say when it should be invoked is limit minus date dot now, and the difference is last ran. So it should be invoked once when we have this difference. This makes sure that function invokes properly after the last invocation. So this gives us the calculated time, and here we are just adding a precautionary check to make sure that this function is invoked only when the difference between last ran and the current time is more than the required limit. So now our throttle function is ready. Let's bring it to test. So if I reload this and if I click on the test button, this hola learners bucket should invoke once immediately on the click of test, and the next call should happen after 2 seconds. So see, I clicked, limit is not defined, sorry, limit is basically delay and delay. Let me update this, and now if I click on test, this console log will be invoked immediately, and after that it will be invoked once every 2 seconds. So see, it was invoked immediately. The second call context sorry, my bad, spelling mistake. Let's test again. So it was invoked immediately, and now it will be invoked once every 2 seconds. So you can see it is being invoked once every 2 seconds, irrespective how many times I'm clicking it. I can increase the duration as much I want to have a better optimization. This is really helpful in the websites where you are continuously refreshing the page. So you can have this throttle to refresh once in a specified duration for a better performance optimization. Another thing I just wanted to show you is like if we are getting the event or not on the click of this, if the context and arguments is being properly passed. So if I console log this value, we should get the event. If I click on text, you see we got the pointer event, and then this is showing that the event has been fired, which means the context and argument is also being passed as expected. This is how you can implement the throttle function. Now throttling also has variations similar to debouncing. So here we did the first call immediately, and then the second call was done after the specified delay. It also comes with a variation of trailing and leading, where if the leading is there, then it will work similar to the base implementation where the first call will be done immediately. If the value is trailing or the option is trailing, then the first call will be made after the specified delay. So that will solve in the SDE2 series. I see you in the next question where we'll solve the clear all timeout method. Thank you.